All right, so this is the first step in our new series on Rust data structures and algorithms. We're just talking about some basic search algorithms today. Linear and binary search. We spent some time on stream writing this little blog article. It's kind of rough. My writing is lackluster. We'll just say that. But it will at least get us started, introduce the concepts, and then we'll write the code for it. Okay, so we're going to start with this. We're going to start with this series. Oh my God, there's a typo in the first sentence. We're going to start this series with the most basic of algorithms. You have a sequential data structure of some sort, a sequence. That's what we're going to call it from here on out. And you want to search through it. How to write a link on Substack. It doesn't look good. It doesn't look good so far. This is on Substack. I don't know if I'm going to stick with it. It's kind of hurting me. I've never used it before. Linear search. Chances are you are already using linear search. Otherwise, I don't know how you do anything in your code. The most common form of this is often done in a for loop construct. In a loop construct, there we go. Like a for loop, spoiled it, in most languages. In Rust, while you can use a for loop and implicitly call .into iter, linear search is accomplished through the find method of the iterator trait. This method takes an implicit argument of mute self and a predicate. A basic implementation of linear search on an iterator. Okay, so let's go ahead and write this code out. I do need to actually create a new project for this and everything, and we'll get that going. I have really, really important things in here so far. Let's just try a little cargo init. Can we do cargo init lib? I don't remember how this works. Sorry, I'm new to Rust. I think that's a joke. Cargo init lib. Okay. Here we go. We're getting somewhere. We've got a cargo.toml. We've got a source directory. This is looking pretty good. And we can go from there. So let's go into our source for lib and see what we have. Come on, Rust Analyzer, you can do it. This is basically an empty project. I think you're going to be okay. Everything's looking good on stream. Okay. So as usual, when you init a lib with cargo, at least with the version I have, it's going to give you a little add function and it's going to give you a test. Yay, that's great. Okay. So let's start by let's just do a little search, search.rs. Maybe we'll do simple search. I don't know. It doesn't really matter. We'll just call it search.rs, and that will be our search module. And we'll go from there. And we just have to go back to our, come on, you can do this. There we go. We can go back to here and we now have a module called search. Yay, I think I did that right. Okay. This will allow us to write tests in here if we really want to, but we're probably not going to for the most part. I always forget the boilerplate for tests because it's just so complicated. So we'll just copy that for now, even though we don't have an add function. So the main things that we want to do is implement a simple search, and we'll eventually implement a binary search. The first thing we want to do is a basic implementation of linear search on an iterator. So what does that look like? Obviously, without using an iterator.find, right? So we have an iterator, and we want to search through it linearly and check with a predicate, ideally, if something works. So let's just start with the simple case, which is going to kind of like roll right into what we do with binary search. Won't the Emacs community not excommunicate you for not doing this org mode with literate programming? Yeah. I actually thought about that when I was writing this blog the other day. Like, now, to be honest, I've never used org mode, but I was thinking, man, I kind of wish that I knew how, and that I was using a program that's actually made well for technical writing. Wouldn't that be something? I mean, I could just write these in Markdown and put them on the GitHub, but I want the email sign up. I want somebody to be able to put their email in and get notified every week. I think that's nice. And I just didn't want to implement something myself that actually requires work. So here we are at Substack. Okay, so simple search or linear search, right? Actually, what I meant. And so let's just start with a function called linear search. And this function takes an iterator, which is probably not the best thing. We'll call it an it. How about that? For now, we'll just take an iterator, and then we'll take a t. And over here, we'll have to say this is a t, and this is an iterator of t. And I think that's wrong, but it doesn't really matter. And it takes a t, and then it's going to actually return. It's up to you. You could return true, or you could return the element, right? For now, I think we'll go ahead and just return a reference to t, and that should work fine. Want all the things without any effort? Yeah, exactly. Okay, so linear search takes an iterator of t and returns a reference to t. And it's just going to be a basic equality check. So what does that mean? It means we have to have partial eq on t, right? So we're just going to do something simple and make this recursive. We could do this with a for loop like we talked about before. I was thinking about maybe including the for loop code, but I think that's probably obvious to most people. I don't know, chat. What do you think? Should we write it with a for loop first and then write it in a recursive way second? I don't know if that really matters. I'm not sure. We're just going to write it recursively to start with. I think that's fine. Yeah, so if we want to rewrite this recursively, it's kind of nice since iterator already consumes itself. We actually don't need anything. I don't think we need anything extra. I think we can be, I think that we're going to be just fine doing something like this, which is going to be if a equals it.next. Then return true. I almost did an explicit return. Who am I, prime? I mean, come on. Else we're going to not return false. We're going to and now there's an error in my code already. If let sum a it.next. I think that's right. Isn't that right? Am I crazy? It.next should return an actual option. Why is Rust Analyzer not working? I thought Rust Analyzer was broken in one of my other projects just because it was broken, but it seems like it's actually broken. This could be a Nix problem. Did I not write a Nix flake for this? I don't think I did, actually. So in that case, it's not a Nix problem. Okay. Interesting. I mean, it's working here, It's giving me some syntax expressions, but it's not working in the sense that it's not telling me those sorts of things. So that's a little confusing, but it doesn't matter. We'll just get the basic algorithm down and then we'll fix our syntax errors. So if let sum a equals it dot next. Right, this is what we want. We actually just want to match, don't we? So let's match it dot next, and if it's sum a, if a equals it dot next, nope. Sum a if a equals a. That doesn't really work, does it? Oh my god, look at me. Let's call this a Q. It's our query. I think that's fine. If a equals Q, then we're going to just return Q. Okay. If we have just a sum a, then we're actually going to recur with linear search and pass it and Q. And finally, if we have none, we return false because we're at the end of our iterator. Nothing matched our query and we're good. Okay, so this should be, if it builds and it actually works, this should be a basic recursive linear search on an iterator. Let's see if it actually works. We don't actually know because it doesn't seem like Rust Analyzer is actually working well. I don't know why. Well, it builds. That's something for us. So let's try a little test here. Linear search works. And what do we need for a test? We need an iterator. So let's start with a V. We can go right to a vec, I think. I think this should be fine. If we just want to say vec 1, 2, 3, not into iter, we'll just let that consume. And then we can say something like, let's see, this is how I know. This is how I know Rust Analyzer is actually not working. Because I can't even get completions. It's fine. Isn't it assert eq like this? I'm pretty sure this is right. Since my LSB is broken. We're gonna say assert eq linear. Let's see. This should be. That's really funny. I was returning. I returned false instead of none. This is good. This is really good, guys. Okay, let's do an option of T. That might make some sense. Everything's going really well. Okay, that makes a little bit more sense, doesn't it? Okay, so then assert eq sum 1. Let's do 3 for fun. Okay, this is a lot of fun. And this is going to be linear search it and 3. Okay. So that's that. Now we actually need to like create our iter every time we run this thing because it's just going to consume it, right? Which is fine. Assert eq sum. Let's just say nope. I meant none. Linear search it and 4. Okay. This looks okay. What is this weird green line up here? File not included in module tree. That's because I did the mod thing wrong, didn't I? Mod search. It's not capitalized. Is that what it is? Is it just like this? Is that what I did wrong? I'm not sure. I don't remember. We'll look it up in a second. It could be also why it built is that it wasn't actually included in our module tree. Okay, now we're actually getting some problems. That's good. Trait objects must include the den word. Oh, right. So when we do a T like that, we're actually just going to make this a U, and we're going to say iterator T. And if we do it this way, we should be happy. There. Okay, that looks good. And then we say if A equals Q, and this is probably because, yeah, that's because we didn't actually do this part right. It's item equals T, if I remember correctly. And then we would actually need to say something like that. Wrong one. Okay, it does look like Rust Analyzer is kind of working. It's giving me some things. Cannot borrow as mutable. Cannot borrow it as mutable. It is not declared as mutable. Oh yeah, right. We have to have a mutable iterator, huh? How about it? Okay. I think that's right. And let's see. Okay, right. So we don't need the sum A since we don't actually use it. And that gets rid of that warning. Let's see if we have any other warnings. Just dead code. Classic dead code warning. Yeah, so I just have to turn off that. Let's see if I remember how this works. I want to say it's like this. What's up, Nightshade? Is that how you allow dead code? I forget. That is how you do it. How about it? All right, let's see if this works. Kind of first try. Okay, we know how to implement a recursive linear search in Rust. How about it? Skill issue? How about, yeah, that's fair. That's fair. Okay, we probably don't need the comment saying linear search above our function called linear search. Okay, so we have our function. It works as far as we can tell anyway. And so that means that we can actually put it in our little code block here. And there it is. We could make this nicer by putting T and U below. If we run cargo format on this, I wouldn't be surprised. If it actually did that for us. No, it doesn't. I'm kind of surprised. A lot of times it would put this on the next line. I don't know. I mean, it's not the most beautiful thing in this format. I think I will. Dude, there's tests. Look at these tests. Look at this. Oh, wait, no, running 0 tests? Oh, no, that's on the other one. Okay. I got scared. I was like, I saw this one, 2 passed, but it's just because of those tests. Okay, we can actually delete those, so we stop getting that. And so Nightshade can't freaking trick me again with me thinking that he's right about something. Okay. Was there even a stand-up? Yeah, I know, right? What do you mean test result okay 0 passed? Doc tests? What are doc tests? What does that even mean? Why are you running a doc test? Okay, sorry. Rust moment. We're good. So even though Rust Analyzer is still convinced that this isn't in our module tree somehow, I'm I'm pretty sure that it works. I have a triple slash somewhere. I don't though. I don't have one. No. This is the only file so far. All right. So we implemented linear search. Let's actually clean this up just a little bit. Just a little bit. We'll add a where clause, and we're going to say where t is partial eq and u is iterator item equals t. Okay. It's the only time I'm somewhat okay with the bracket being on the next line. Okay. And this should still all compile and work. Okay, looks good. Everything's happy. Let's replace our code that we had. Actually, we could just replace that one line. We'll just replace this with that. That's a little bit more readable for the kids at home. Function linear search takes a mutable iterator, a query, returns an optional of that query. Okay. So now that we did that, let's actually make it take a pred, because it'll be nicer that way. So it's gonna take a pred now. And pred is actually, so I'm gonna switch this around a little bit. I'm gonna say iterators are t, p is our pred. Okay. All right. Actually, I'm gonna need t still, right? So actually, iterator is still u. Just kidding. Just kidding. Okay. Where t partial eq u iterator item equals t. And p is a function mute. I always forget this syntax. I don't really care though. We're gonna look it up. It's just right here. And that is find on iterator right here. Self item to bool. Okay, sure. So instead of doing that, of course, we're just going to say t. Okay, right. Function mute t to bool. Okay. There we go. Now we have all of that done. And why? Yes, please save this file. I really want you to. I know we haven't used it yet, okay? We're about to. I did not tell you to delete that whole effing line. Why do you keep doing that to me? Emacs? Emacs, why are you doing this? Search.rs has changed. Okay. Let's click down here. Okay. Mini buffer was not behaving. Oh, it's killing me. Killing me. All right. All right, so this is a little different because now we don't have a queue. And so we have to do something a little bit different. And ideally, actually, we take a reference to t here. And then here we can say if p and a, then sum a. And then this, we just replace the p, and we should be good. You don't like this? You don't like this? Oh, because now it's not a reference. Because of the way the iterator works, it probably doesn't actually need to be a reference, because then we have to implement like the whole lifetime thing and everything. So we can actually, since we're consuming the vec and everything, we should be able to get away with this. What don't you like about my pred? Okay, let's just run the full thing. Oh, it's just it's actually the errors in my test. I always do that. I'm not looking like it's the problem with locality of errors, right? Okay. So now we're just going to do a linear search. This is going to end up being sum3, and our pred is just going to be something like this. I think this will work. I think this will work. We'll find out. And then to be n equals 3. Okay. That looks okay. And then we're going to do the same thing here where we do and n equals 4. Okay. Sum3 is not the same as 3 sum. Okay, good to know. All right, so this looks good. And we will just cargo test, make sure it looks fine. Cannot borrow as mutable. What do you mean cannot borrow? Oh, because it's a function mute. So I know they say it's a function mute, but I actually don't need a function mute. So we're going to just change our predicate to be not a function mute. I kind of hate that the predicate would be a function mute, to be honest with you. So let's not. So our ours is going to be here. All right. So I'm pretty happy with this. I think this is a simple, nice implementation of linear search with an actual predicate. And there you are. Linear search. You'll learn Rust not to let that info go to waste. Dude, whimsically. It's just any language with optionals or maybes, you know. A generic version of linear search on a slice. So let's write a little function, a linear search slice. And this one, instead of, do we still want to do the predicate? I think, let's see, that just checks for equality, because the whole point is that I'm leading us to binary search, right? A version, okay, so instead of saying a generic, I'll just say a version of linear search on a slice that just checks for equality. I think that's nice. So for linear search slice, we're going to need the type of our item, the type of our slice, which I probably don't need a type parameter for. And really this just has to be partial eq. And then we have our actual slice. Okay. So our slice is here. It's going to be S, and S has a type of nt. And then our query is going to be Q. It's going to be very similar to the code we just wrote. The only difference is here I actually have to keep track of index, so I am going to need like a separate function to do that for me. Have you tried ternary search? We just keep going down, Nightshade, like tertiary search, quadratic search. We just keep going where we're like, yeah, we're gonna split this even more. This is gonna be so good. That's funny. And it doesn't make sense in a way as well, of course, but that's okay. Okay, linear search slash t is partial eq, and in this case, we're not going to return that option. We're just going to return a bool. This is kind of just a contains, but it's the same sort of deal, right? So we're just going to return a bool because I want to. So the main thing that we're going to do is we're going to say do linear search slice, really long function names, because we're writing Rust and you have to write long function names, right? And we're going to say sq0, and then we have to actually write that function. Okay. Maybe I will do this. No, it just feels bad. It just feels bad, even though I kind of want to. T is partial eq. And S, I should have just copied that, obviously. T, and our index is usize, and it returns a bool. Okay. This looks pretty good. And how does this work? We basically just, since we have index on slice, we can make that work pretty simple. It's going to be a lot like the other one, right? The main conditional is going to be if I is less than s.len minus 1. Let me think. Do we just want s.len? Yeah. If I is less than s.len. Yeah, that'll work. Then we can do our stuff, right? If it's not, then we're at false. We're at the end of our slice, and we didn't get anywhere. So if I is less than s.len, then we're going to say if as I equals q, then we have true, else we are going to recur. Okay, sqi plus 1. Okay, let's see all the mistakes I made. Let's see. Yeah, I know the sized problem, and that's fine. Let's see. Let's just get the full error output. I forget how to fix this right now. I know, right? It makes sense. It's totally reasonable. S doesn't have a size known at compile time. The trait size is not implemented for... Oh, right. So we can either put it in a box or we can take a reference. So we'll like typically how you work with slices, it's the same as like and stirs. right? You take a reference. You don't usually do what I did. We're just taking a reference to that slice. Solution shorten functions to characters three letters long. That is definitely more my style. Okay. So we have a bunch of dead code. Even though I wrote allow dead code up here. Does that not count? Does that not count for everybody? Amit. Hey, Amit. It's been a while. I hope you're doing well. Thanks for the follow yet once again. I hate that dead code warning. It's so dumb. Okay. So let's just say linear search slice works. If you want a long function name, I mean, yeah, I figured you were just busy. I mean, if it would have gone another month, I probably would have made sure that you know, like you were okay, that I didn't super offend you. No, I didn't see you on any other streams, so figured it was just busy time. I wish they had a compile flag to collapse certain warnings. That would be really nice. I'm forgetting how I usually fix this. So what we'll do is we'll do a little head-n1 on our v0. Is that not what I called it? No. Did I call it v1? Okay. And like, we're not looking at this code, right? We're just, that's what I forgot. I forgot the bang. The bang is what makes it work for the whole file. Okay. That was it. Okay, linear search slice works. So we create a slice. We can do this a few different ways, but let's try doing it this way. I guess we could do an array, right? If we just do our same amazing test case, something like this, I think would give us a slice, if I'm not mistaken. This should be the right type. We'll see what happens. Since my IntelliSense doesn't like to work and tell me what type things are anymore or anything like that, I don't actually know what happened. I think I tried an eglot restart even, didn't I? We'll just do an eglot restart while we're busy here. Maybe we'll get lucky. I probably fucked something up in my Rust install because of Nix. Realistically, that's what happened. Okay. Anyway, we'll say assert. Since it returns a bool, we can just say assert linear search slice. And we should be able to just pass in that little s. Remember, kids, Nix, not even once. I called eglot IntelliSense and it got yeah. That's fair. That's totally fair. All right. So we will search for 3 yet again, and we'll see what we did wrong. Or maybe it's just first try. Is it first try? No, of course it's not. Expected that. Okay, so this ended up not being a slice. So I think I can just call an into, because there should be a function for that. There's not. Just kidding. Forgetting how to create a slice. It's really good. What is that? An array. Array. Okay, as slice. Okay. This is what happens when you don't have your LSP working. Okay, so that gives us an ante. An ante. All right, so let's try this. I think this should work. And then we'll go here. This is the first day, dude. You didn't miss anything. We wrote a blog post the other day, but that's it. Okay. So we're here. This is fine. All I have to do now is I don't have to do this, so we won't. We'll just keep it there. And all that means is up here, we'll change this. I kind of thought that I was being silly about that. We'll change this to this. I can't remember if that's necessary. I think it is. I think it's going to give me an equality check. Equality problem? Yeah. Okay, cool. Look at me knowing things. I was waiting for you. No, I was just waiting for you. Hey, Prophet, what's up? How you doing? Okay, linear search slice works. It does work, at least for our extremely good cases. I forget what the assert is. I fucking hate not having auto. Can I say assert not? Is there an assert not? I can't remember. This is so dumb. Assert not equal. Okay. But there's not like an assert not, right? Okay. That's fine. What? Oh, maybe let's see. Asserts that two expressions are not equal. Assert any. Yeah. Okay, but that doesn't help me. Cuz I mean, like, what's the difference between saying assert eq false versus the other one? I don't know. Shut up, Alice. No, I'm just kidding. Yeah, it totally is. I'm so not used to having a not operator, even though I know that's a thing. Oh, I don't have excuses. I'm just being dumb. All right. First try, even though I forgot that I can just use a not operator. No, I mean, yeah, I was trying to come up with an excuse, and that's why I stopped myself, because I started being like, oh, it's because I don't. Never mind. I have it everywhere. Oh, you know it's bad when Nightshade can correct you? Seriously. Okay, look at that. Linear search didn't take long at all. Okay. Let's look at this code and see if we can make it better real quick. If I is less than s.len, if and si equals q, true. There you go. Yeah, that would be totally worth it. That would be so worth it. That's going to crash on very large slices, by the way. Yeah, you mean because of exceeding the call stack. Let's see. What was I thinking about? Oh yeah, let's see what we want to do here. Like this logic kind of sucks, right? It sucks a little bit. If I is less than s.len, if and si equals true, else. I mean, I'm trying to think if there's just like a nice fall through option here. I mean, obviously I could do this. It's the same thing if I just go here. We could do that. I think. Oh no, but then I have to do an explicit early return. That's why I don't like doing that. I hate explicit early returns. I don't want that. What am I not thinking about? If I is less than s.len, then we do this, and it's true. Else do linear search slice. What's wrong with earlier returns? I think it just reminds me too much of C, I guess. I mean, I think most people would probably do the other thing, right? If I is greater than or equal to s.len or something like that, then they do their little return false and then go on. I don't know. It's almost tempting. It doesn't look so bad. Perfect code. Did you try to use find inside the linear search? It will reduce code. Yeah. Thanks, Amit. I appreciate that. I don't know. Is there any other way to make this terser? I'll take chat suggestions now. I mean, the code works. It's not like you're fixing code for me. You fixed my assert. Of course, it's really dumb to do an if and then return a true. I hate doing stuff like that. I guess there's or. Does that work? Can I do it like this? And as I equals q or do, will that work? Linear search slice sq I plus 1. I mean, I guess we can do this. I don't know if this will work. Let's just delete this. Oh my god. Wait, you don't like early returns, but that thing is fine. Yeah. Fine, Prophet. Fine. Hey, look at that. I mean, you hate this? I don't hate it. I don't know why. It's just a simple, like, okay, well, if it's not this, then we're gonna fall through to this. I don't know. I guess it is kind of crappy. It's knowing that, I don't know. I'm gonna go with it. This is probably how I'm going to keep the linear search, by the way. Sorry about that. Do linear search slice. It's so ugly. Do you guys hate it? Do you really think that I should go back to the other one? Like, if you think that it's better for readability, I will. It probably is, isn't it? It is pretty ugly. All right, fine. Of course, I already did iterators. Dude, I did an iterator. Look at this. Look at this. We did linear search with an iterator. This is just showing a linear search on a slice. All right. All right. We'll go back to this. Okay. Fine, guys. Fine. Weren't you here for that, Nightshade? Are you just trolling me right now? Okay. This is okay. Let's actually switch the order of these functions. I think that's going to make it more clear. Why are you giving me a grammar suggestion on fucking code in a code block? What the fuck are you doing? Oh my god. Unbelievable. Okay. Let's just put this up here just for being somewhat consistent and not confusing me when I look at this later. Make sure that I'm not too dumb. And we're ready to go to binary search. Okay, so we got our version of linear search on an iterator and linear search on a slice. Linear search is simple, but depending on the number of elements being searched, it can be slow. Or if you don't have tail call recursion and you do it this way, it could never end. As the name implies, linear search takes linear time in the worst case, aka O in time complexity. Okay. I guess I should put a note that this could exceed the call stack. Yeah, why not? No, this could exceed. This could cause stack overflow on large slices. Okay. Yeah, when I read for like whether Rust really has TCO, I got a lot of weird answers. There's not a very clear answer on the internet. Oh. Dude, Amit, you're late. You're late to that joke. Nightshade beat you to it already. Enter binary search. To beat linear time when searching a sequential data structure, we can use binary search. The basic idea of binary search is that it splits the search space in half at every step, the drawback being that it only works on a sorted sequence. Binary search works by halving the sequence, comparing the query to the middle element, and recursing to the half that could contain the query. An example in pseudocode. Let A equals 1, 3, 5, 8, 13, 21. Let middle equals 3. Let query equals 13. Let first second equals 8 out split. Okay, so we were just going to rewrite this in Rust. I guess we can. We'll do that after we actually write binary search. It doesn't have tail call elimination. They're working on an explicit become keyword, though. Okay. An LLVM might eliminate tail calls as an optimization, but that's nothing you can rely on. Yeah. Okay, cool. Thanks, Alice. Yeah, I like some resources were like, yeah, in some cases it can, and some places were like, no, it doesn't at all. You're not joking about ternary search, yeah. BQN doesn't have tail call elimination either. Is that because you guys only work with data sets that are like less than 10 elements? Just kidding. Okay. It's because Marshall doesn't like it. Nice. That's basically why. Reasonable. A basic binary search. Okay. Because we're splitting our search space in half at each step, binary search takes logarithmic time, aka O log n. The Rust standard library includes a binary search method. Okay, on slice. So let's just look at that method real quick. Just to make sure our API kind of goes similarly. Oh, that's interesting. They return a result usize containing the index of the matching element. Right. If there are multiple matches. Oh yeah, returning an index makes a lot of sense. I probably should have just done that. It's kind of silly. It's interesting that they decided to do a result. Why did they decide to do a result? If the value is not found, then result error is returned containing the index where a matching element could be inserted while maintaining sorted order. Oh, that's really cool. We won't do that, but it's a cool idea. Yeah, it's kind of dumb. I should have just returned a result. I mean, an option of usize. let's change this to option use size. That makes more sense, doesn't it? Okay, if and si equals q, then we return sum I. And if not, we just return none. I like that better. Let's just update our code. And now we're back to this. Instead of having it contains, it's actually more like a real linear search. You're at least getting something back. So this should be sum2. And this should be none. What did I do wrong? Cannot apply unary operator. When did I do that? Oh. It's funny. Use the wrong thing. Okay, that works fine. Let's change this for our linear search. Makes a hell of a lot more sense. Oh, I'm gonna undo my note. All right, it's fine. Such a pro. It's taking me this long to do linear search. Can you imagine me trying to do an actual whole data structure in one stream? Hopefully I won't be as bad next time. We'll pretend. We'll pretend that's true. Okay, basic binary search on a slice is going to be very similar to how we started up here. So we're just going to copy this for now. And change this to binary search, except we don't have to call it slice because we're not doing this anywhere else. And there's that. Okay, so binary search returns an option use size, and it takes a slice of t and the query. That looks good. The main thing that we have to do, of course, is choose our midpoint, which is going to just be half and then recur down. A lot of people do this in like a partition function, but I don't know if that's really necessary. Or am I thinking of quicksort again, where people do a partition function? Maybe that is what I'm thinking of. That's probably what I'm thinking of. I keep doing that every time I think of binary searches. I think of quicksort. Oh well. It's so funny. Oh God. Why? Okay. Yeah, we don't need a second function, do we? Okay, so let's say let mid equals s.len divided by 2, which of course Prophet hates me for. I do actually forget, like what is that gonna actually return? Like it's just gonna return like what, 9 divided by 2 should return. Does it round or does it lower? Okay, yeah, it just cuts off the, yeah, it's just like it does that and then the rem, the modulo or whatever, right? Okay, that's what I thought. Okay, since we're not in pseudocode, we can do that. Maybe you only hate it in pseudocode, which is fair. All right, let mid s.len divided by 2, and then this is simply an if as mid equals q. We're gonna need a little ampersand there though. Then we return mid, else we have to do this whole thing, where we take part of the slice, and I don't remember how to do that, but we're about to look at it. Oh, wait, slice, I can actually do that with range syntax, can I? I think that's true. Yeah, okay. Else if and as mid is, nope, wrong one. If Q is, oh my God, what am I doing? If Q is less than, and S, I'm hitting all the wrong buttons, and S mid. To annoy your coworkers, you could do S dot. That is really funny. I mean, just you know, do a little bit operation. Oh God. Okay. If S mid equals Q, right. This is a sum. Right. Okay. I'm probably not doing this in a smart way yet, but that's okay. If Q is greater than S mid. No, if Q is less than S mid, then I think we can do this. 0 dot dot mid. I forgot the if there. Else if Q is greater than S mid, then, and we forgot one base case, which we'll get into in a second, which is if we mid dot dot S dot len. Oh, actually, if you just do this, doesn't that work? So actually I don't need the 0. Maybe I'm wrong though. I have to look into range syntax. I forget. I don't use it very often. Oh yeah, we don't need this for binary search because we just do that. Okay. And we don't need do. It's completely different, guys. We already knew this, but you know. Is this a recursive algo session or you like it more than loops? Yeah, pretty much. I just like implementing things in recursion, and obviously in a language without TCO, it can go either way, right? But I mean, I think binary search especially is annoying to, I mean, like binary search is like a recursive algorithm. I mean, right? Am I wrong? Okay. So I think my range syntax is wrong. Let's just look that up real quick. Rust by example. Really? You can do it iteratively. It's just kind of subtle, yeah. Okay. Makes sense. Let's see. Really, Rust by example, can we find a range? You don't think you've ever done a binary search without messing up the search boundaries? That makes sense. For n in 1.101, I was hoping they would explain, oh, it can be for a range inclusive on both ends. Yeah. Okay, so I did it right. And I think slice has index trait implemented for ranges. So this should work, except I don't think this works. I'm guessing I can do that. I might actually have to grab the len. I can't remember. Okay. So this would be inclusive of mid though. Yeah. So that's the part that's annoying. Is this is inclusive of mid? Stupid. So I mean, what? We do this? That's really beautiful code. I don't even know if that compiles. Okay. If and s mid equals q. So up here is the last part. Woke code. Yeah. I don't know what that means. I don't get the joke. That's okay. Maybe it's better if I don't. If s.len is greater than 0. My help. It's making an effort to be inclusive. Good. We try to do that here. Return none. Okay, now we're going with an early return just to make this code simpler for the time being, while we find out if I even wrote it right. I probably didn't. Did I put $1 instead of an ampersand? My DSA series on where I know Rust better is not going so well. Okay. Expected option use size found unit. Where? Else if q what? On q greater than s mid. Why? Because it can't tell if this is I guess we'll just return in none at the end. I guess we could. Oh, because I have to have a final else branch. Duh. But if it's not equal, less than, or greater, then that's a problem. So I guess we just have to actually change this code to not have that explicit, right? I'm not used to that coming from places that don't care, such as Clojure. Binary search, expected and t and found t. Okay, so let's see if we can just do this and make that happy. It looks fine. And yeah, of course, I forgot about partial ord. So this is already going to get ugly enough where we should just turn it into a where. Partial ord plus partial eq. And that looks okay. Yay. I need to return from the recursive call. I think I am. Am I not? Oh my God. I said if s.len is greater than 0, return none. Wait, that's OCaml. That's Rust. Okay. Rust does not save you from logic errors, does it? Oh, okay. Well, let's see if this works, and then we'll make the code not look like it's completely simple. Binary search works. Let s equals. Let's do our example from the blog, because I think that's nicer. Our fake Fibonacci example. Gotta love that. It's because on my keyboard, X is Apple key if I hold it down. It's a modifier key. So a lot of times if I'm trying to copy something on a Mac, I'll end up typing XC if I don't hit it right instead of copying it. I don't know about the Q. I don't remember seeing a Q. Okay. What are we doing? Oh yeah, we're doing binary search. Okay. So let's see. Let's do one that's lower and higher and equal, and we should have some idea that we did this right. So let's say binary search S and 3. And then this, let's make this, we'll do 21. And what are we at? 5? That's hilarious. Might have switched those numbers around. 5, and then we'll do a none case. None for binary search. Oh, it doesn't really matter, but sure, we can do 2. Why not? I don't know what that is, Amit. What do you guys think? Is my algorithm going to work? It didn't run it. It just would run linear search works. Why aren't my new ones? Why didn't it run the test? What happened? Why is it only running linear search works okay? And it's not, oh my God. Oh my God. I forgot about this tiny important detail on Rust tests, which is you kind of have to annotate each test. Be really funny if they all failed. It also helps if you save your file and you don't mistype. Be really funny if the slice one failed too. Yeah, no, it absolutely panicked. This is good. This is really good. Oh, because I'm doing an index access somewhere. Failures on binary search works and linear search slice works. Okay. What are you so frustrated about, whimsically? Hopefully not with me. See you, dude. All right, let's see. Tableware. Ugh. Tableware is really, really frustrating. All right. Yeah, no worries. Have a good one. Okay, so I made a mistake in a couple of these. Let's see if we can figure out what it is. Let's go ahead and remove this one so we can fix the first one. So our linear search slice works. We get panicked at left is none and right is sum equal sum 2. Oh, that just means that our test literally failed. Right. Okay, good. Oh, because I forgot to change the freaking thing I was passing. No wonder it works. Okay. So we didn't have an error in our logic. We had an error in our test. This is why you shouldn't write tests, guys. This is why writing tests is bad. All right. And what about this one? Left is sum 5 and right is sum 1. Okay. And this is on 71. Kyle Wiggs, what's up? Thanks for the follow. Hey, Kiav, what's up? Hope you're doing well. We just have to see if we have an error in our test or an error in our binary search. So this says it's line 71, which is here. And apparently it returned some 1. Oh, duh. Oh, duh. Doing a binary search and returning the actual index in the original array is annoying. It's annoying. That's why you shouldn't do it. All right. No, we can do it. We just have to think a little bit. We just have to think a little bit, don't we? It would require some, so it's either we change this to a bool, which is essentially like it contains this item, or we actually return the index. I don't know. One second. Oh dear. The usual implementation uses start and end indices instead of slices. Yeah. That makes sense. Right, right. And that's when you need that second function. It would make things easier. I'm kind of interested in solving it this way for now, though. So let me just pretend like I can. I mean, I know I can. I think... I mean, basically, what's the difference? So if you have an array of 10, you split it in 2, right? And then... So basically, no, that's a bad way of doing this. Let's do it down here. So obviously, like... Wait, how did it end up getting 1 though? Now I'm really confused. How did it end up that 21? How did 21 have index 1 at the end? Shouldn't have had. Oh, because 1 divided by 2 is 1. Oh, wow. Oh, wow. Okay. Duh. That's really stupid. Yeah. Yeah. Right. So it's always going to return 1. That's why the other one passed. I see why people do this with start in indexes now, because this is really annoying. Oh, yeah, right. 1 divided by 2 equals 0 with truncation. So how did that work? How do we end up with sum 1? That doesn't make sense. Let's just do a debug print of the slice at this point. You prefer the loop variation with high and low? Yeah. How do I want to do this? Yeah, I mean, the code's going to be ugly either way if I spend all my time doing this. So let's just do... Let's do it this way. We will say the query is in T, and then we have our high and low. High is usize, low is usize. Okay. So for now, let's just put all this here, even though it will get changed. And here we also need this. This is why I should have just copied it. All right. This is dumb. Why didn't I just copy this? I don't know. Because I have a hard time learning from my own mistakes, I guess. I don't have a bracket. Okay. Sometimes. Okay, so on our original, we're going to say SQ, and high and low is going to be, I don't know why I did this that way, but it's fine because we changed it already. So our low use size, high use size. And our high and low should be 0 and s.len minus 1, right? I just like spaces sometimes. Okay. So here we don't really have to. So this base case is going to be a little bit different. So this is going to be high minus low divided by 2. And then what are we going to say? We're going to say if S is mid, or if the Q matches the mid, then we're going to return the mid. Otherwise, one of the nice things is we could just make this on any index trait, but it's fine. We'll just keep it as slices to make it simple. Otherwise, we are going to pass it into here. Hey, F collector, what's up? Binary search is one of those really simple algorithms that is kind of annoying to implement, right? Okay, so if Q is less than mid, then our low isn't going to change, but our high is, right? So then our high becomes mid minus 1. And similarly, well, I'll just delete this because typing isn't the thing that takes the longest. I say as I make many mistakes. And our low ends up being mid plus 1. And our high stays the same. Okay. So let's just walk through an example real quick. Let's say RS is in fact what we have. 8, 13, 21. Okay. What ends up getting passed in? You're no longer frustrated. Brackets around the mid calculation. Yeah, I know. You mean just order of operations. It's fair. You've calmed down a bit. I'm glad. I'm glad that you've calmed down. Now, it would be really funny if this just worked. I really doubt it's going to, right? This isn't going to work. All right. Stack Overflow. Let's go. Yeah, I forgot about the important part of actually putting in a base case for when we don't actually find our query. Love it. Gotta love it. Okay. Yeah. I already forgot that I didn't put the base case in. Do you also not know the difference between a coupe plate and a dinner plate? I can't say that I do. Yeah, I know. I usually just, I'm just a very polarizing figure. So what is our base case in this example? Our base case is if high equals low, right? Is that right? I think so. Mm-hmm. I mean, I guess we could do it here as our second. Else if high equals low, then low will never exceed high. Oh yeah, you're right. Yeah. That's true. I'm trying to think if this works though. I know that's like the normal way is people do a if low is greater than high. What's funny is I'd rather just implement a linked list than this. Return none. Okay. All right. Let's just try that for now and see if we still get a Stack Overflow. Still get a Stack Overflow, which means we did something else wrong, which is fine. Let's just run through this. Okay. So with this slice of 6 elements, our initial high and low is going to be 0 and 5. 5 minus 0 plus divided by 2 is going to end up being 2. So we're going to go ahead and check, does mid equal 2? Does the query equal mid? And it would be at 5. And we would say, no, it does not equal that. Is the query less than smid? Let's say it's 3. Yes, it is less than smid. So then we're going to do a binary search where our next low is going to be 0 and our next high is going to be mid minus 1. And that would end up being 2 minus 1 is 1. Okay, so now we have it with 0 and 1. 1 divided by 2 ends up being 0. Yeah, there's something wrong with the mid calculation, actually. I feel like that's possibly the problem. You think if I just put an equals sign, my Stack Overflow goes away? I really didn't think this would be this hard. I'd done this before. The Stack Overflow did go away. What's funny about it is we still have the same, like we got a none, right? And that's because the logic is wrong. Okay. I'm not done yet, dude. This is taking way too long. I should have done binary search on a different day than linear search just to pretend like it wasn't that hard. Mine was doing mid -1 equals 0 -1. Yeah. Okay. Anyway, let's just run through this again because I'm making a mistake, and it's probably just me being stupid. Lies you tell yourself. I know, right? It's all gonna be just as painful as last time. Okay. If S mid equals Q sum mid, this is fine. That part's fine. I feel like a problem is in my mid calculation, actually. I think there's a problem there. I think there's a problem. I wonder if my high should actually be exclusive instead of inclusive. I wonder if that buys me anything. I kind of feel like it might. I guess we'll just print debug some shit and see what happens. Let's see. Print line. S and print line mid, and down here let's just print line Q. Oh yeah, S isn't going to change though. S will always be the same. So actually it's just high and low that I want. Okay, that's what I want. So let's just do high, low, mid. Try removing -1. Yeah, I'm just going to do it this way first. I mean, but I appreciate it. Let's do this. I think there's a thing I have to say in order for it to actually print while I'm running a test. I just have to remember what that is. What? Oh, because it doesn't implement debug. Okay. Well, that's easy enough to fix. Plus debug. You gotta be fucking kidding me. Stud format debug. fmeat. Okay, cool. So while searching for 3, we end up panicking with some 1 and none. That makes sense. And what do we start with? The very first time we start with a high 5, low 0, mid 2. Exactly what I thought, right? The next time we have a high 1, low 0, mid 0. Yeah. And so our mid doesn't ever actually catch the 3. I think if I do it this way, I think this might actually get me get me there. Like Amit said. Okay, cool. So now we get onto a Stack Overflow. That's fine. I'm fine with the Stack Overflow. No. And that's because I'm not actually. Let's see. Why? Oh yeah, this is before I define mid though. I guess it's fine. Let's just put it up here. I didn't mean to do that. I meant to yank it. And we'll just delete the mid part. Why does it not print the logs when it errors? There's something that I have to do and I always forget what it is. Rust print logs. Let's see. Cargo test logs at error. Because it never flushes, yeah. No capture, yeah, that's it. Do I have to do the whole dash dash no capture? No. Using this rather obscure command, cargo test, dash, 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 dash. Oh, there's no dash. You're right. You're right. There we go. Okay. So it gets stuck on this high 5, low 2, mid 1. Okay. And we can probably figure that out. High 5, low 2, mid 1. Okay. So before that, it's going to go for a while. I don't have time to find out. So it gets stuck at high 5, low 2, mid 1. Okay. So let's just run through this again. If we're searching for 3 in this slice, our first mid ends up being 2 as an index 2. That's fine. It doesn't equal index 2. So we end up being here. Oh, well, we never changed. No, yeah, low and mid. That makes sense. Why is obviously I don't need both of these now. Yeah, just self-loathing, pretty much, PM walls. Pretty much. No, I thought it would go really nice this time. I thought it was going to go really well. That's why. Okay. I don't know what's wrong with me at the end of the day. That's really what it comes down to. We have 5. I wish I could think. I'm a little upset. I thought this would just be like smooth sailing. Right now I'm searching for 3. So I'm walking through it. We're getting there. Just let me cook. All right. Else if Q is less than... I haven't solved something hard on stream in a while. I think that's the problem. I've been doing too easy stuff, maybe. I don't know what's wrong with me. It's whatever. Okay. So if 3 is less than 5, which it is, we're going to do a binary search where the low is still 0 and the mid is okay. This is something I don't understand. Is how in the fuck did we end up with 5, 2, and 1? How do we end up with 5, 2, and 1? If our query is that, or maybe the Stack Overflow is on the other one. Oh, I didn't even think about that. You know what? It might actually be the 21. I bet it is. I think that's the problem. Let's see. Let's just do this real quick and see what happens. We still get a Stack Overflow? No. Okay. That one's working. Okay. It's because the 21 branch is wrong. Okay. That's good to know. That should have been an obvious thing to check. So this is wrong. I kind of think the mid plus 1 might be the problem, but let's just run through searching for 21 and why that never actually happens and why we end up with a Stack Overflow. And let us remember what we're stuck on: high 5, low 2, mid 1. Okay. Unbelievable. Okay, so if we have this slice and our high is 5 and our low is 2, then our mid is not high minus low divided by 2. That's the problem. That works. That works for the first half of the that works for the first half of the slice, but it's not going to work. It's not going to work for the second half of the slice. Oh God. Why did I think that would work? I'm a little annoyed. It's the midpoint between the two. And so if you want to get to the midpoint between what was it, 5 and 2, then you would actually want to add them and then divide by 2, not subtract them and divide by 2. Okay. I'll take the not Stack Overflow. Okay. So that part's better. Now I think it's probably just this. I actually think we want if low is greater than high. Because if low equals high, it probably just means we're at our very last element. And we're back to a Stack Overflow. Okay. I guess I was wrong. Now, what's funny is I think we're on a Stack Overflow on our last test now. So it's that if it can't find anything, we're on Stack Overflow, right? Yeah. Okay. Beautiful. Okay, so why are we on a Stack Overflow here? Is it because I didn't just put a fucking base case? I don't know. Let's think if we need a different base case. Yeah, no, I totally got it. Once I remembered the whole like high and low thing of meat, the iteration thing makes a lot of sense. Good. I'm glad I'm making people feel better. That's what I'm here for. Okay. Oh, got it. Damn it, Nightshade. I didn't know that's what it was. Oh my gosh, I can't believe it. This is going to be an hour and a half video on linear and binary search, guys. I don't think the original goal of making shorter videos went very well. I don't think it worked. no, don't tell me a meat. I'm trying to figure it out. All right, just give me a second. I'm so mad right now. I'm so mad at myself right now. Oh, God. Yeah, exactly. It's too funny. Oh, you think it's my initial problem is here? All right. I'm going to go with a meat suggestion, actually. All right. I actually thought of that, and I forgot that I wanted to try removing that and see what happens. A meat's wrong, as usual. A meat. Can you imagine listening to a meat? Why did it say mine is... No, that's right, actually. Getting binary search right in a reasonable amount of time feels like pure RNG for me. It's just the simple things. It's just boundaries. It's so simple. I know that, but then it fails, dude. Then it fails. Oh wait, no, I'm dumb. No, I'm not dumb. No, it was failing. The problem is, okay, sure. I think what you're saying is I need greater than equals here, and I need this, right? Let's see if this okay, it fixes it. You're right. You're right. Okay. So let's just talk about this real quick. So I was able to fix it originally. First try. This is the most not first try binary search ever. Oh, it's the most first try, not first try in any imagination. Okay, so let's just look at this. For 3, we start with high 6, mid 3. We go to high 3, low 0, mid 1. And that happens to be our array, so like our actual answer, so we're happy. With 21, we start with high 6, mid 3, like we always do. We go to high 6, low 4, which gives us our mid 5, and that ends up working out for us. With 2, we hit 6 and 3. We hit 3, 0, which brings 1. And 1 and 0 gives us the correct mid of 0 to check the very first element. And it's not there. Okay. Oh, God. Yeah, sick. That's actually what happened. I'm just having fun. We actually did that in record time. I don't think anybody's ever done a binary search faster than that. And if this was an interview, I would not get hired. But also, if you asked me to do a binary search in an interview, I'd probably be like, why? Why do you want me to do that? Your mid cal without overflow. Oh, mid low plus high E. Oh, okay. Since low plus high could equal. Oh, I see what you're saying. So that you don't get the integer overflow. Is that what you're talking about, Amit? Yeah. That's fair. Oh, God. Okay. So we finished binary search. We finished linear search in basically just a couple minutes. Let's see if there's anything I want to change about this. Is there anything I want to change? So many things. There's so many things I want to change about this. But that doesn't mean I'm going to. I actually think this is fine. Like it's kind of it kind of sucks. I don't love it, but it's fine. What? You just want me to open this link? Oh, Rust DSA, quick and easy. Stack Overflow's lifetimes hundreds of hours later. Okay. You know, that's actually right. Lots of people could not write mid calculation. They added stood midpoint in C++. That's hilarious. Okay, so let's put this in our blog and we'll ship it. I think I copied it already. A basic binary search on a slice. It only took me an hour and a half. Oh, I didn't copy it all. Nice. I don't think it took me an hour and a half, but it wasn't short. Oh, I did the same thing again. I'm so used to having to define a function before I use it because that's a closure thing. Oh, that's perfect. That's exactly where I wanted it. How did you know? There we go. Can you imagine implementing this and saying in a code block, I'm still going to show you spelling errors? Can you imagine doing that? I don't know. Maybe it's not their fault. Maybe it's Grammarly that's doing it. I'm not sure. But either way, it's dumb. Wait, I don't have Grammarly installed on this browser. Never mind. Everything I just said is incorrect. Okay, let's do this. And delete here. We have a perfectly working binary search. There's no effing problems with it at all. And we're so good. Okay, how about it? Defining property for prototype first in use. Yeah, I don't know. It is kind of weird. I'm pretty sure order of definition matters in Clojure. Maybe I just made that up right now. Who even knows? Who even knows with me? Okay, this was binary search. How about it? You may be wondering why we didn't implement binary search on an iterator, and the main reason is that an iterator consumes itself. So we can't just compare to the middle element and then recur down the first half. We could recur down the second half if we wanted, but this would mostly fail to actually find our query unless we used another data structure to store the elements along the way, which defeats the whole point. If you weren't wondering, I'm sorry if you just read that whole paragraph. We looked at two ways of searching through a sequence. Linear search is more flexible, works with any predicate, not just a comparison function, doesn't require sorting, but takes linear time. Binary search only works with comparison functions, requires sorting, but is much faster on larger datasets, taking logarithmic time. In the next post, we'll talk about linked lists and implement a singly linked list in Rust, which literally will probably not take me as much time as implementing binary search, because honestly, linked lists, pretty fucking simple. All right. Thank you so much for watching. Hit like, hit subscribe. I hope this will get better. I hope it's not going to take me an hour and a half to do something simple in the future, but we never really know. This is just what you get with me.